Hello, I'm Sonic. We will learn about partition on integration. Here we see the newly interested ones. Partition on integration is sometimes called Riemann integral. This comes from German mathematician, Bernhard Riemann, 1826 to 1866. Riemann integral was the first rigorous definition of the integral of a function on an interval. For many functions and practical applications, the Riemann integral can be evaluated by the fundamental theorem of calculus or approximated by numerical integration. Here we show you an area under the curve. We can find some errors on the marking. To minimize errors, we may have to increase the number of subdivisions. Note that delta x is the width of each strip that tends to 0. This makes the result in this form. This can relate to quantization of noise in analog and digital signal processing. One on the other depends on its speed and velocity. Let's discuss it with miles tails per hour. Tails, what do you see for the application on integration?
I taught about speed and velocity.
In velocity, what do you measure in terms?
Meters per second.
Okay. Take x be the distance. When we differentiate with time, say dx by dt, this becomes velocity.
Yeah.
Definitely.
That's why we get meters per second after differentiating it. If we again differentiate it, we get an acceleration. Length per unit square time called meters per second squared.
That was an interesting application.
Okay, see you soon.
Thanks. Now, back to this topic. When you increase the number of strips, this reduces an error in the decimal value. It is not necessary to be regular in this form. Let's take f, which is a real valued function defined on the interval a and b. For Riemann sums, we take summation from I equal to 0 to n minus 1, f of ti times x of I plus 1, minus xi. Each term in the sum is the product of the value of the function at a given point and the length of an interval. Consequently, each term represents the signed area of a rectangle with height f of ti and width x of I plus 1, minus xi. The Riemann sum is the area of all the rectangles. We can derive in two parts, one for the upper and the other called lower. Upper sums can be called supremum, and the lower called infimum of f on each subinterval. These are called Darboux sums. In Riemann integration, we say that the Riemann integral of f equals s if the following condition holds like this. We write the above part for the Riemann sum, minus s in entire modulus, minus epsilon. Unfortunately, this definition is very difficult to use. We use Darboux integration. We can therefore write, limit integration from a to b, f of t dt equals upper Darboux integral of f, which is also equal to lower Darboux integral of f. For example, if we range from 2 to 12 and divide into 8 subdivisions, like in metronome of each and every beat. Take x0 equals 2, and x8 equals 12, all you have to do is to do the partition. The middle one is x4, the average is 7. Between x0 and x4, x2 equals 4.5. Between x0 and x2, x1 equals 3.25, this makes a difference of 1.25. The one which we relate to arithmetic progression. Thus, this is the partition form including 8 subdivisions. And I only ask you for the upper and lower sum example. Let us do the same, with definite integral x squared dx. In general, we write in this form. Upper limit sum, equals, in uppercase m1, times x1 minus x0, plus till uppercase mn, times x of n minus x of n minus 1. Similarly for the lower limit sum, in lowercase m of sequences. In upper limit sum, we accept for the first term x0, and in lower limit sum, we accept for the last term. To find the upper limit sum, we start with x1 value with delta x be the difference. But, you have to put the value x in the integration as well. When you write it and solve it, we get 663.44. Similarly, to find the lower limit sum, we start with x0 value with delta x be the difference. This gives an answer 488.44. So, I hope you now know how to use Partition. Like, comment, and subscribe now on YouTube.